been given the problem of having two cylindrical pools that are being filled simultaneously at the same rate. So the volumes of both pools are equal over time. The larger pool has a radius of 8 meters, the smaller pool has a radius of 5 meters. We're given that the rate at which the water level is rising of the smaller pool is 0.5 meters per minute. And we're trying to find the rate at which the larger pool is rising. So first we draw a sketch of our pools. We want to note that this is the radius of this pool is 8 meters, the radius of this pool is 5 meters. We know that the smaller pool is rising at a rate of 0.5 meters per minute. Second thing we want to do is arrange our data. We know that our constants are 8 meters for the large pool, 5 meters for the small pool. The radius is constant. The radius is not changing in either of the pools. We do know that the volume is changing in both pools, but at equal rates. And we know the rate at which the smaller pool is rising. So, second thing we need to do is find the volume equation for a cylinder, and that is V equals pi r squared h. Now we want to notice that the variable that is changing here is the h. The r is constant, the h is what's changing. We also want to notice that the problem has given us the rate of change of h for the smaller pool. And we're solving for the rate of change for the larger pool. So basically what we have here is a ratio. And so the first thing we'll do is label our pools so we can keep our information straight. The big pool here I've called big H, and the little pool I've labeled small h. The two things that are changing are our volume and our rate at which they're rising. So we have dV over dt equals pi r squared d big H dt, and basically the same thing for the smaller pool. I've decided to use little h in the rate there. So now I take the two equations, and since their volumes are changing equally, the dVTs of both of them are the same, so I'll set the equations equal to one another. You can plug in your constants, which is your 8 meters and your 5 meters, your radiuses. And remember, we've been given the h dt up here is the 0.5 meters. So we've plugged that in here. Now we just need to solve. We get 64 pi over d big H dt equals 25 pi over 2. We do our math. We solve. We get 25 over 128, or approximately 0.95 meters per minute. Now, just a quick gut check, make sure that we're doing this right. We should expect to see a positive rate of change because our smaller pool was rising is a positive rate. And we should also expect, since the larger pool, since the 8 meter larger pool is bigger, that it should be increasing at a slower